CCNA version 7, Enterprise Networking Security and Automation version 7, Final PDSA, Packet Tracer Skills Assessment, the addressing table, Router A, Router A, Router B, B, Router C, C, Router 1, Router 2, Router 2, Router number 3, PC11, PC21, PC41, PC11, PC21, PC41, servers, Corp server, Net1 server, Corp server, Net1 server, laptop LT1, and web server on the cloud, all with IP addresses on the interfaces. Configure Ospf, activate Ospf. Use process ID 10 for Ospf activation on all routers. Okay, all routers. Activate Ospf by configuring the interfaces of the network devices in the satellite network where required. Okay, there are two networks. This is satellite network. Okay, satellite network and corporate network. Two networks, satellite and corporate. So activate Ospf by configuring the interfaces of the network devices in the satellite network. Okay, activate Ospf, process ID 10, and configure interfaces on Ospf on satellite network. Okay, on these three routers, A, B, and C. Very nice. And configure routers ID. Configure routers ID on the multi-access network. This is the multi-access network because there is a switch. Okay, satellite network is a multi-access network, and corporate network is a point-to-point network. Okay, so router IDs on the multi-access network, A, B, C with IDs, A, B, and C with IDs. So go to router A, okay, router A, enter, enable, configure terminal, router Ospf 10, okay, remember is 10, for A is 9, router A is 9, router ID 9. Configure the interfaces. Okay, use the interfaces method exit, and you have three interfaces on this router. Three interfaces. And do the following command to show IP interface brief, and you can see three interfaces with IP addresses, three active interfaces. Okay, but do not include Ospf on this interface serial 011. Do not configure Ospf on serial 11 because you don't have here Ospf neighbor. This is internet. So you don't need Ospf on serial 011. Okay, so do this on gigabit interface and serial 010. Interface gigabit 000, IP OSPF process ID 10, and area, only one area 0, 0, 0. And this another interface, serial 010, serial 010, the same command. That's it. Okay, very good. And the next router, router B, enter, enable, configure terminal, router OSPF 10, router ID. For router B is 8. Okay, and exit to show IP interface brief. 2 active interfaces. 2 active interfaces. IP OSPF 10 area 0. And on the another interface, the same command. Okay, very nice. And okay, this is the neighbor adjacency with router A. The neighbor adjacency with router A. Okay, our router C. Enter, enable, configure terminal, router OSPF 10, router ID 7, exit, do show IP interface brief. 2 active interfaces, 2 active interfaces. IP OSPF 10 area 0, gigabit 001 OSPF 10 area 0, exit. Now activate OSPF using network statements and inverse mask on the routers in the corporate network. Okay, on corporate network, configure OSPF using network statements and inverse masks. Okay. Router 1, enable, configure terminal, router OSPF 10. Remember, is process ID 10 for all routers. And do show IP route connected. You have 3 active interfaces with 3 directly connected networks. 3 directly connected networks. Okay. Network 10.10.0 wildcard for 30, the wildcard is 3, the area is 0 for all, the area is 0. Enter. Okay, and this is the neighbor adjacency with router A. Okay, and continue to 40. Same wildcard, same area. 248. Same wildcard, same area. Okay, 1, 2, 3. Exit. Enter. Okay, router 2. Enter, enable, configure terminal, router OSPF 10, process ID 10. Show IP route connected. 3 directly connected networks. 3 directly connected networks. Network 10.10.0 240 wildcard 3 area 0. Okay, be careful, is 240. Okay, and this is the neighbor adjacency with R1. The neighbor adjacency here on network 240, and the next 244, same wildcard area 0, and network 192, 168, 33, 0, wildcard for 28 is 15, area 0. Enter. That's it. And router 3, enter, enable, configure, terminal, router Ospf 10, do show IP route connected. 4 directly connected networks, 4 directly connected networks, network 10.10.0, 244, wildcard 3, area 0. Okay, be careful, wait a moment. Neighbor adjacency with R2, 248, enter 248 now. Okay, this wildcard 3, area 0. Wait a moment. Neighbor adjacency with R1, enter network 192, 168, 44, 0, 24. The wildcard for 24 is 255, area 0, and 55, 0, wildcard area 0. Okay, enter. Next. And you can verify and go to router B, for example, enter enable show IP routes. Now you can see the networks on Ospf 236, this 240, this 244, this 248, this directly connected network 116, this 116, directly connected network 11.0, 11.0, Ospf 22.0, 33.0, 44.0, 55.0, okay, 22.0, 33.0, 44.0, 55.0. Very nice. All is working very good. Okay, this is ready. This another statement is ready. Now customize Ospf operation. Configure router A with the highest Ospf interface priority so that it will always be the designated router on the multi-access network. This is the multi-access network. So this interface on router A, this interface, gigabit interface, gigabit 000, is part of the multi-access network. Okay. This interface is part of the multi-access network gigabit 000. Okay. So configure gigabit 000 on this router. Enter enable configure terminal interface gigabit 000 and configure the highest priority IP Ospf priority 255. Exit. Okay, so it will always be the designated router. And the same router A, configure the default route to the ISP cloud using the exit interface. Okay, so configure a default route on router A to internet. So the exit interface is serial 011. 011. IP route, the default route, interface serial 011. Enter. Don't worry about this message, serial 011. Automatically distribute the default route to all routers in the network. So advertise this or redistribute this default static route on router I to another routers on the network. Router Ospf tag default dash information originate enter X. Very good. Configure the hello and dead timer values on the interfaces that connect router A and router 1 to be twice the default values. Okay, on this link, the link that connects satellite network and corporate network, this link, configure these interfaces, serial interface on router A and serial interface on router 1. Okay, and modify the hello and dead timers to be twice the default values. Okay, and go to router A and show IP Ospf interface. Enter. And the interface is serial 010. Serial 010 is this serial 010. The hello timer is 10 and the dead timer is 40. So change to be twice. Change to 20 and 80. Okay, on serial 010. Configure terminal interface serial 010. IP Ospf hello dash interval 20 and dead IP Ospf dead interval 80. Okay, the same configuration on the another side on router 1 serial 020. Enter enable configure terminal interface serial 020. Okay, IP Ospf 10 and IP Ospf hello interval 20 and that interval 80. Okay, exit. Okay, that timer expired. Interface down. Okay, but now neighbor adjacency. Okay, the connection is restored. Neighbor adjacency with router A. So this is very good. And configure the Ospf router so that the default cost value for all gigabit Ethernet interfaces will be 10 and the cost value for fast Ethernet will be 100. Okay, the default reference band Y is 100. On Ospf, the default reference band Y is 100. So this is a gigabit interface, 1000 million, and this is a fast Ethernet interface, 100 million. Reference band Y of 100 means 100 million. Okay. So if you will calculate the cost for a gigabit interface, the cost is 0.1, and this will be 1. Okay. And for fast Ethernet interface, calculate this, and the cost is 1. So the cost will be 1 for gigabit and 1 for fast Ethernet. Instructions says gigabit cost 10 and fast Ethernet cost 100. So if you configure this, you will not get if you configure this, you will not be able to get the score. This is an error. Okay, this is an error because this should be for gigabit will be 1 and for fast Ethernet will be 10. For gigabit will be 1 and for fast Ethernet will be 10. And this calculation with reference bandwidth of 1000, and 1000 means 1000 million. Calculate with gigabit interface is 1 and calculate with fast Ethernet is 10. Okay, this should be 1 and this should be 10 because you will not get the score. Okay, and enter. Configure on all routers router RTRA router Ospf 10 auto dash cost space reference dash bandwidth 1000. Okay, this is the case, 1000. Enter and exit, and do this for all routers. Okay, please ensure reference bandwidth is consistent across all routers. Copy this on Notepad. This method is very fast. Copy this and paste on router B. Enter, enable, configure terminal, paste. Very good. C. Enter, enable, configure terminal, paste. Very good. Okay, router 1. Global configuration mode, paste. Very good. Router 2. Enter, enable, configure terminal, paste. And router 3. Enter, enable, configure terminal, paste. Very nice. Okay, very good. And configure the Ospf cost value of router 1. Interface serial 011 to 50. Okay, on router 1, this interface serial 011, configure cost to 50. Okay, and you can verify show IP Ospf interfaces. Show IP Ospf interface. Okay, and serial 011. This serial 011. The cost is 647. So give a lower value. Okay, configure terminal first serial 011 IP Ospf cost 50. Okay, exit a lower value. Okay, so this interface will be preferred for traffic. Configure Ospf so that the routing updates are not sent into networks where Ospf updates are not required. Okay, this is the configuration of passive interfaces. Okay, on router A, this interface serial 011 is not part of Ospf, so router Ospf term, passive interface serial 011. Okay, this interface serial 011. Enter. Okay, and copy this for faster configuration. Okay, exit. And on this interface, on this router, this interface gigabit 00000 passive, because you don't have another router here. You don't have an Ospf network. Router Ospf 10 passive interface gigabit 000. That's it. The same way on this interface on router C gigabit 000. Router C, router Ospf 10 passive interface gigabit 000. Exit. Router 1, no passive interfaces on router 1. Router 2, the passive interface is this gigabit 000. Router Ospf 10 passive interface gigabit 000. Exit. On router 3, 2 passive interfaces. Okay. On router C, 2 passive interfaces. Gigabit 000 and I guess gigabit 001. Okay, gigabit 000 and gigabit 001. Router Ospf 10, passive interface gigabit 000, gigabit 001, exit. Configure NAT. You will configure a static and dynamic NAT at the network edge. Where is the network edge? Is this router A, because it's close to the cloud. Configure static NAT. Configure static NAT to translate the address of net1 server. Okay, net1 server, this server, on LAN 1, okay, on net 1 or LAN 1, to the public address 192.168.115. Okay, the private address of net1 server is this 192.168.11.100, 192.168.11.100, and the public will be 192.168.150. Okay, so configure. And do this on router A, on the network edge. Router A, global configuration mode, IPNAT inside source static. The private address, this 192.168.11.100. The public address, this 192.168.115. Enter. Very nice. Ready. But configure the NAT interfaces. This interface serial 011 interface serial 011 will be IPNAT outside. Okay, outside, because goes to internet. And this another gigabit 000. Gigabit 000 is inside. Gigabit 000 inside. Enter. Exit. Okay, very good. And verify that the translations are occurring. So you can ping from internet, from this web server, you can ping this net1 server using public IP address. Go to web server, and ping the public address of net1 server, and is this 192.168.115. 192.168.115. Success. Verify on router A and show IPNAT translation. Okay, the inside global is the public IP address of the Net1 server. This is the private IP address of Net1 server, and these two are the IP address of the web server. Very good. Now configure dynamic path. Create an access list number one, this standard access list number one, to allow all addresses in this network 192.168.0.0.16 network to be translated. Okay, this network with this prefix includes this network, this another, this, and this another. All the 192.168 networks. Go to router A, configure terminal access-list1 permit. Okay, because allow number one. Okay, one permit this network 192.168.0.0 prefix 16 on wildcard is this. Okay, enter. And now create another pool, name it pool -1 case sensitive. Okay, IPNAT pool, use this name, pool -1 case sensitive. Space. It should use address in the range 192.0.2.116 to 192.0.2.118. Okay, use the range of addresses 192.0.2.116. The last is 192.0.2.118. Okay, should be 192.0.2.118. Okay, this is incorrect, obviously, but should be this. And don't forget the net mask. And net mask is not specified in the instruction, so it's part of this network, of the serial 011 network on router A. So verify that serial 11 interface on router A 192.0.2. Okay, and the net mask is 29. So go to router A, net mask is 255, 255, 255, 248. That 248 belongs to the prefix 29. Enter. And this is the access list, this is the pool. Finally, configure NAT to dynamically use the addresses in the pool. Remember that it's likely that more than 3 hosts will be accessing traffic on the internet. So use path port address translation. Okay, because on this range, on this pool, you have 116, 117, and 118, 3 IP addresses. If you have 3 IP addresses, the pool is enough. But if you want more than 3 hosts will be accessing traffic on the internet, you need to activate overload port address translation. Okay, so IP NAT inside source list. The list is the number 1. Pool. The pool is this pool. And activate overload for port address translation. Enter. Very nice. Now configure NAT interfaces. This interface is already configured for outside. This another is configured for inside. Okay, outside, inside, and don't forget to configure this. And don't forget to configure this interface serial 010. Serial 010 is inside. Okay, the face serial 010 IP NAT inside exit. Okay, and obviously verify. For example, go to this this laptop. Command prompt, ping internet, ping the IP address of the server. This ping 203.100.113.100 success. Go to router A and show IPNet translation. Very good. This is the public IP address of the PC. This is the private IP address of the laptop. This is the IP address of the server. Very good. Finally, configure access list. Okay, use host and any keywords whenever possible. Always explicitly configure the default deny condition when it is to be used as part of the access list functionality so that it can be logged when the condition is met. You don't need to specify the default deny condition if it is counteracted with the permit IP any for this assessment. All access lists should be placed in the most efficient location possible according to the guidelines specified in the curriculum. Okay, use host and any keywords. Configure the default deny condition. And use permit IP any and place in the most efficient location possible. Okay, first access list, create a named standard access list. Okay, name it a standard access list. To explicitly prevent all external traffic accessing the telnet lines on router 1. But where is router 1? Is router A. Okay, click on router A and you will see the prompt shows router 1. Okay, so router 1 is router A. Okay, so prevent all external traffic accessing the telnet lines on router 1. Name the list BTY block. Okay, and go to router A, computer terminal, name it IP access list standard. Use this name, case sensitive, BTY-block header. All addresses on the 192.168.0.0.16 network only should be allowed to access the BTY lines. So only permit this range, okay, and this network. So use permit 192.168.0.0. Wildcard for 16 is this. That is enough. Enter. And don't forget configure the default deny condition. Okay, here there is a implicit deny any, but configure always explicit. Okay, configure explicit deny any. Okay, exit. And for the BTY lines, okay, so assign this access list on BTY lines. Line BTY, all lines 0 to 15. Oh, sorry. Line BTY 0 to 15. Access class. The name of the access list BTY block. Case sensitive. Incoming traffic. Okay, is an incoming exit. Is an incoming traffic trying to access the BTY lines, the telnet lines on the router. Okay, so verify. For example, from this PC should be permitted on PC11. Use this telnet SSH client. Use telnet because it's telnet lines the IP address of the server. This IP on gigabit 000 on router A is 10.10.1.17. Okay, go to 11.10.10.1.17. Connect. Yes. No. Okay. This is a packet tracer issue. Okay, because go to check results, go to assessment, go to router A, and the access list is very good. BTY block, access list. The access list is very good, BTY block, and the configuration on the line is very good. So close this. Go to router A. Maybe you can fix this and show running config space. And you don't have a password. You don't have a password here, so you can implement a configure terminal line bty 0 to 15 password Cisco login exit. Okay, and try again. Go to PC11 and go to the telnet SSH client, telnet. Use this IP 10.10.1.17, 10.10.1.17. Connect. Password Cisco. Very good. You are on R1. Exit. But try to connect, for example, from router B, and should not be permitted because will be in the network tank. Okay, go to router B, enter enable telnet. You can use the same IP 10.10.1.17, 10.10.1.17, enter. Connection refused by the remote host. So the access list is working very good. Okay. And create a numbered standard access list to prevent all hosts on LAN 1. LAN 1 is net 1 from accessing LAN 2. LAN 2 is net 2. Okay, net 1 is the source, net 2 is the destination. Okay, and okay, and net 1 is the source. Net 1 is the source. This is the source. Net 1 is the source. And net 2 is the destination. This is the destination. This is the destination. Okay, and draw a line for the direction. Okay, and okay, and this is a standard access list. It's recommended to implement a standard access list close to the destination. Close to the destination. So this is the destination. Should be implemented on router C. Implement on router C and implement on this interface, this gigabit interface. But I know if you implement the access list on this interface, you will not be able to get the score. So configure here on this another interface. Okay, this is the most efficient location, the most efficient place, but it should be implemented here on this another interface to get the score. Router C on this interface, okay? Okay, go to router C, enter, enable, configure terminal. The numbered access list, access dash list, use number 10, prevent, so deny, host on LAN 1. Okay, so the source is LAN 1, and LAN 1 is this 192.168.11.0. 192.168.11.0 wildcard. And on standard access list, you will not be able to configure the destination, but the destination is this LAN 2, is very good. Enter. Here there is an implicit deny. So if you will use deny here, you will need to permit any other traffic. So use permit IP any for another traffic. Access list tag permit any. Okay, for standard access list is this permit any. Enter. Exit. And configure on gigabit this interface gigabit 001. Configure terminal interface gigabit 001. IP access group 10 incoming traffic. 10 incoming traffic. Incoming traffic. And exit. Verify. Ping from 11 to 21. Ping. What is the IP address of 21? Is 22.22. 192.168.22.22. Destination host unreachable. Very nice. Access list is working very good. If you will ping from the laptop, will be permitted. Okay, ping from the laptop. Ping 192.168.22.22. Success. So access list is working very good. And finally, I now create an extended numbered access that will prevent traffic from LAN 4 from accessing the HTTP service that is running on Corp server. Okay, LAN 4 is net 4 to HTTP service that is running on Corp server. And Corp server is placed on net 3. So this is the source, net 4, and the destination is the server. Okay. Okay, the source is this. This is the source. And the destination is the server. The destination is not the network is only a host is the server. This is the destination. Okay, and draw the line. Okay. Okay. It's recommended to place the extended numbered access list. It's recommended to place the extended access list close to the source. So it should be placed on this router 3. Okay. And the interface close to the source will be this interface, this gigabit interface. Configure on this gigabit interface. And it's incoming traffic on the interface, incoming traffic. Now you can see the arrow. Okay, incoming traffic. Okay, and go to R3, enter, enable, configure terminal. Number extended access list, the number will be 1 of 1, access dash list 1 of 1, and prevent traffic, so deny. Okay, HTTP uses TCP, and the source is LAN4, is this net4. You can specify the network address 192.168.44.0. Okay, but anyway, use any but you can use any as the source, any device on this network, any device on this net4, use host and any keywords whenever possible. So make sense any device in this network. Okay, deny TCP from source any, and destination is only one host. What is the IP address of corp server 192.168.33.14? The destination is the host 192.168.33.14, and this is equal to 80 because HTTP uses port 80, or use www is the same. Okay, enter. And here there is implicit deny any, implicit deny IP any. Okay. If you will use deny on this line, if you will use deny on this line, use permit IP any to permit any other traffic. Otherwise, you will deny all traffic. So use this access list 1 of 1, permit IP from any to any. Okay. Ready, and remember, place on this interface gigabit 000 incoming traffic. The gigabit 000 IP access group, then the number 1 of 1 incoming traffic. Enter, exit. Okay, and test the ping access. Try to access from this PC to HTTP server on corp server. Go to PC41 web browser 192.168.33.14. Enter. Okay, wait a moment. Request timeout. Very good. The access list is working, and go to laptop, close command prompt, open web browser, and try to access 192.168.33.14. Success. Very good. Finally, manage network devices, configure NTP, configure R2 to use corp server as its time source. Okay, configure this router too, and corp server will be the time server for R2. Go to R2, enter enable configure terminal NTP server. NTP server 192.168.33.14. Okay. Okay, and now backup iOS to the server, backup the iOS image on router R2 to corp server. Okay, this is a TFTP server, and go to router R2 and copy the iOS image. But what is the iOS image? First verify, show flash, enter. This is the name of the iOS image. Okay, so copy from flash column to TFTP column, enter. The source file name is this, the iOS image. Copy, paste, enter. Address of the remote host, address of the server 192.168.33.14. Destination file name, use the same, enter. And wait a moment, but may take a while. Please be patient. Wow, finally, okay, very good. And look at this, the completion 94%. Go to check results. Okay, and the NTP server on R2. This is an issue because R2 is, go to R2. This configuration is very good, so don't worry. This is okay. Okay, ignore this. The routes on Ospf on router 1. Okay, this is router 1 with 3 directly connected networks. This is very good. You can verify. Okay, you can do the following and enter enable configure terminal and show IP route. And now you can see the following. Okay, directly connected networks 236, 240, 236, 240, Ospf 244, Ospf 244, directly connected network 248, 248, Ospf 116, 116, 11, 22, 33, 33, 44, 55, 11, 22, 33, 44, 55, and the default route connected to internet, and the default route for the connection to internet. Okay. So Ospf is very good. Okay, we do the following: show IP route connected. Only 3 directly connected networks. Only 3 directly connected networks. Show running config. 3 directly connected networks configured on Ospf. Very good. Let's look at this. 1, 2, 3 serial interfaces. But look at this. There is another interface that is not in use. So you can advertise this. 66. Okay, configure terminal router Ospf 10. Remember, it's 10 network 192.168.66.0 wildcard 24. Wildcard 24. Okay, it's not 24. It's 255. Okay, enter. Okay, don't forget alias here. Exit. And now you got 96%. And there is a missing route, but don't worry, this is an issue of packet tracer, and also the server. All is very good. Thank you very much.